Good evening, guys. Tonight we're going to be talking about shapes of data points. The first shape I'm going to talk about you're really familiar with, and the second one is the new concept that I'm really wanting to focus on in this video. All right, go ahead and title this Central Tendency and Dispersion. Okay, and your essential question is, how can you measure the dispersion of a data set? Okay, central tendency, you guys are pretty familiar with already, and that's that mean median mode. You guys have worked with this since 6th grade, pretty familiar with it. I'm going to do a quick review though. The one I really would like to focus on today is measure of dispersion, and that's that range, which we practiced and you practiced before. That won't be too hard. But the standard deviation, completely new, okay? Is a comparison of how much the differences between the data sets means. So there when your standard deviation is big, that means that the between the numbers for the mean is big. When the standard deviation is small, that means your data set's kind of clustered together and close together. And that's the big picture we're trying to see. So let's get started. Of course, standard deviation has a formula. Super important that you write down this formula because we will be referencing it multiple times today in this video. Okay, we also need to understand what all of these symbols mean. So don't freak out on me yet. We're going to talk about what these symbols mean. Okay, so N is the number of values in the data set. Okay, so you just count the number of values there are, and that's what you're going to divide by. Okay. This symbol, this X with this bar above it is X bar. Okay, this X bar represents the mean. Okay, and the mean should be the same every time. The same every time. Okay. This dot, dot, dot underneath the square root means that you're going to add each of these values up depending on how many data values you have. So we'll get into it in an example. Okay, but here's your big picture that I need you to write down. Okay, a small standard deviation means a small number. When you do all of this work up here with the square root, is that the numbers are all close together. And the big picture, what does that mean? You have something that was pretty if I gave you guys a test and I had a small standard deviation, meaning most of you got around the same score. Okay, if my standard deviation is large, I gave you a test and I had a big standard deviation, that means a lot of you got 4s, a lot of you got 1s. It's all over the place. They're not, the majority are in the 3 range. Okay, so let's go ahead and start reviewing mean median mode first. Okay, mean means average, median means middle, mode means most often. So let's start with the mean. The mean is the one that takes the most calculation, and you will need it for the standard deviation. So I'm going to pause my video, okay, and I'm going to figure out what the mean is right now, and I'm going to replay, okay, so you do the same too. Pause your video, figure out what the mean is, play when you're ready to check. All right, so I paused my video and I did all of that adding up of all of those wages here, and I got that all together it was $58.80. Okay, so now I'm going to divide about how many there are. There's 8 of them, and my mean now is $7.35. So an amusement park hires students for the summer. On average, they pay the students $7.35. Okay, the median, the middle number, median, I will have to put these all in order from lowest to highest, okay, to figure out what the median is. And once I did that, okay, I went through and I did that, I got that the median was between these 2 points here. There's 2 points, 725 and 799. So what I had to do between those two is I had to add them together and divide by 2, find out what was halfway in between them. So I added them together and I got $15.24, divide by 2, figure out what's halfway between those two numbers, and that's $7.62. Okay, so the median, the middle number between the highest and the lowest point, is $7.62. Okay, now let's talk about mode. The one that occurs the most, the one that people get paid the most, is $7.25. That one wasn't hard. All right, that was a quick review. We're going to move on now. All right. 2 reality cook shows select 12 contestants each. The ages of the contestants are shown in the table. Find the mean, the average, the range of them, and compare our results. So these two have weight, they have meaning. So let's go ahead and find the mean. I'm going to pause my video again, figure out my mean so I'm not wasting your time. You pause your video and try it yourself. Okay, so when I added up all of show A, I got 300. So now let me label this as mean. Okay, so 300 divided by, there's 12 of them. On average, there's 25. The ages of the consultants are shown. Is the age, years old. Years old. Okay, B, the mean for this show B is, I got 312 is the total of all the ages added up, and there's 12 contestants there, so the average age there is 26 years old. Okay, the range, to find the range, we're going to take the highest minus the lowest. So the highest value for show A is 31, so 31 minus 19 is the lowest, and that equals 12. So 12 years is what we're looking at. Years is the range. Okay, so the range for the second one is the highest is 48, and the lowest is 12, and 48 minus 12 is 29 years. Okay, what do these values tell you? What does 26 years, 29 years, 25 years, and 12 years tell you about the data? Okay, show A, it tells you that they have a younger, their ages are closer together because they're 25 years old on average. Okay, and then 26, they're younger on show A than show B. It also tells you that by the range is 12 years versus show B is 29 years. Show A has ages that were closer together than show B. The data was spread out more than show B. Okay, so show B probably has the oldest person out of the two shows than show A does. That kind of counts into that 29. All right, now we're going to look at the two shows using standard deviation, okay, because this is what we're really wanting to focus on. This is our new thing. So from our example before, example 2, I'm grabbing all of these data points from it, okay? So all of these X's represent all the ages that were listed in those two tables. Like this is a table, show A had 20, had 29, had 19, had 22, had 25, had 27, had had two 27s, had 29 again, it had 30, it had 20, it had 21, and it had 31. So this is just looking at show A. This is from show A's table from the previous slide, okay? Okay, the mean, this means the mean, the average was 25 at each time. So what did we do to find the average was we added them all up, okay, and then we divided by how many there are. Okay, that's how we got this X bar. Okay, now to find the next value point here, the X minus X bar, what did we do? We took X, 20, minus 25, and 20 minus 25 is negative 5. We have to do this for each value, each data point, okay? 29 minus 25, 4. 19 minus 25, negative 6, okay? Now we're going to take that and we're going to square it, and negative 5 times negative 5 is 25. 4 times 4 is 16. Negative 6 times 6, negative 6 is 36. All right, this is all going to play into that formula from before. So the formula is the square root of, it said we're going to add each and every one of these up, okay? So I'm going to add them all up, meaning I'm going to do 25 plus 16 plus 36 plus 9 plus 0 plus 4 plus 4 plus 16 plus 25 plus 25 plus 16, I'm running out of room, plus 36. Okay, I'm going to add all of those up, and then I'm going to divide by 12, because there's 12 points in our data. Let me just double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, and when I do all of that, I will get the square root of 212 divided by 12. Okay, 212 divided by 12 is about, it's a repeating decimal, so it's about 17.7. Okay, so now I'm going to take the square root of it, and I will get the standard deviation is approximately 4.2. Okay, so now we got to interpret our results. So we can do all that work. Quick multiplication division. Okay, what does it mean? It means that the typical age from show A differs from the mean about 4.2 years. So typical age for the mean differs by 4.2. That's telling you how much 8 years you're going to have in between the average and the next data points. All right. Now, again, this is about deviations. Okay, we're looking at those deviations. What I would like you to do is go ahead and find the mean, range, and standard deviation of the data sets, and press play when you're ready to go over answer. All right, for student A, you should have gotten that the mean, the average, was 26, the range was 22, and that the standard deviation was about 6.9, okay? For student B, you should have gotten 20 for the mean, 13 for the range, and 4.2 for the standard deviation. We're going to compare them now. So in comparing student A to student B, student A's mean, range, and standard deviation are all greater than student B's. So they send more text messages. They're not very consistent in their text message. Okay. All right. 2. For team A, you should got 3.5 mean, 0.6 range, and 0.2 standard deviation. So everything's pretty close together with that 0.2. That's pretty small. Okay. Team B should have gotten 3.5, 1.1 for the range, and 0.4 for the standard deviation. And when comparing, the means are equal, but Team B's range and standard deviation are greater than Team B's, which means Team B's has a little bit more distance in between their mean. Okay, go ahead and answer the essential question, take that checkpoint. I hope you guys have a good night. Bye.